it knows who I am. All right, cool. Meeting recording started. Let me share that window again. There we go. So we did some pre-triage here. So we were going to go down. I guess we'll go briefly through these things, the ones that are most important. This item we're going to cover at the end, right?
Yeah, let's. I would suggest we go through async await.
Yeah. Okay, we'll start with that. So for async await, the current status, there was some question around async unsafe FN, but I think we've resolved that. We do intend to stabilize the current behavior.
Yes.
If you didn't follow along, you can do so. We need the basic. I think at this point most of the blockers are down, but we want to improve the test suite, and that's the major thing.
So the one thing I noticed is that we have no tests that check that if you call an async unsafe function and you don't use an unsafe block, that you actually get an error. So that would be good to check.
Sure.
I will just add it to the list.
Sounds good. I don't know. I think most of the things are assigned at this point. So, is there anything else to say about that?
Not from my part, at least. Does anyone else have anything?
Okay. Let's see. Which one next? So briefly, this type ID, we don't really have anything to add to what we said before, except that we plan to put it on some kind of list of pre-RFC interesting thoughts. I think did we order everything else down here? No. So we were going to talk about beta unwinding by default. Do we want to talk about that now, or is it more of I can't remember what we said. Central.
I don't think we did say in the triage meeting. I would make the suggestion that this does urgently need to get resolved, but whenever we start talking about it, it will fill a substantial amount of available time. So we may want to see if there's any higher priority items first.
All right, so we're going to defer that. I think let's talk about the coherence, or is there something else on this list? Stabilize never type again.
The never type again change.
That I thought we were going to do after the.
I think the never type is easier to it's maybe easier to make progress on it because the coherence stuff is like it's like tricky type theory that is like.
So all right. So there's two problems with never type, but the one we wanted to focus, or with the never type stabilization. But one thing we wanted to focus on was, we said at some point we should try to be forwards compatible with the fact that there doesn't exist some impl or other, and I don't remember. Maybe somebody wants to talk about it.
Yeah. So the one that I remember was the impl of from and into to allow you to convert bang to any or never to any type. We can't write that today because of it requires a more advanced version of specialization than anything we currently have. And also,
yeah, it's that one.
Right. So there was some conversation around, like, my sort of preferred option for this is that we just stabilize what we have today, and that since we know that any from or into impl that takes the never type as an argument, it must be equivalent since they're all uninhabited. We can just accept them all. But obviously that's like not an like uncontroversial or like obvious language change, right? So
can you repeat what you just said?
Yeah. So any implementation of from or into for bang. So for instance, I should back up a little bit and explain why this is important. So the feature compatibility hazard here, right, is that someone could write an impl of from some specific type for T, right? And that would conflict. And in fact, we want people to do so for their error types, right? And that would conflict with the impl of from bang for any type, right? The sort of trick here, which is the thing that I was suggesting, is that since from bang has the impl has one associated item, which is a function, and that function takes as an argument an uninhabited type, you know that all implementations of from bang for any type must be equivalent, because they're all just those function bodies are all unreachable and uninhabited. But obviously that's like not obvious, or maybe non-obviously that's not obvious. And so I think there's like reasonable cause for objection to just doing this, with that sort of as the plan going forward, right?
But so the other plan might be specialization, right? Like, are you saying we would?
Right.
If they stabilize what we have today, go on.
If we had a format of specialization that was forward compatible with introducing this impl without breaking those existing impls, I don't know what that would be. I don't think any of our existing formulations of specialization would allow that.
I don't think there's anything that would let us write that formulation in the language, but it's theoretically possible we could effectively implement that impl as a built-in in the compiler.
Yeah, we definitely could.
Why wouldn't we, if we had...
The reason we cannot implement, the reason we cannot do it...
why wouldn't we, assuming we had specialization, I know why we can't write it today, assuming we had specialization, sure. Why wouldn't it permit this impl to be added backwards compatibly?
Because I don't know what specialization is that allows that.
The problem is that you could have, if you add the impl, you would have negative reasoning problems, because credit can rely on the impl not being implemented for example, built-in types. If we do not implement it today, then...
Yes, okay, yeah, that makes sense.
So
that's right. That was the missing thing I'd forgotten about.
So I missed this part. What exactly is the bit of negative reasoning that we allow?
The impl doesn't exist. You can write code that only compiles is only coherent because the impl does not exist.
Right. So
for your own types?
Yeah, for your own types.
I don't think you could
because we just can't add blanket impls backwards compatibly, like unless they have a name in them that is new to this version. You cannot add a blanket impl. But I think that like we should accept that we either will not have this impl or have to have some special case magic for it. And we should not, like, it's been years, it will continue to be years. I think that like the utility of this impl or the utility of not having a special case are less than the utility that people would be getting from bang in the time until we could someday solve this problem.
So there was some suggestion that we could like pretend that the impl exists, but not like reserve it so that we could add it in the future, but like not make that guarantee so that we can remove the reservation if we wanted to. I think that was option 2 in ADVs.
I mean,
right.
I don't know how hard that is to actually implement, but yeah, something that's like pretend it exists so that you can't do the negative reasoning bit.
Right. That might like
possible. I mean, there's like a predicate that says what are the kinds of things you're allowed to know, and it would be pretty hacky, but it's plausible that we could say you're not allowed to know from bang.
It feels like reservation is a hack, so yeah, it's a hack, but it's I'm fine with. It's a temporary hack.
I mean, if we're gonna do that hack, can we just do the hack to have it implement from?
Because that's a permanent hack.
Sorry, say that again.
No, it's a hack until we like. It's not any more permanent than what you're proposing, because when we write the impl, we would instead write the impl. Like,
well, the point is we could throw away the hack and change nothing else, and we haven't affected anybody. But if we
that's true. I mean, I think we should just. I just think we should stabilize bang, and whatever we'll do is that like. So this whole situation is like way too much like perfect the enemy of the good. Like,
So I think we should stabilize bang, but I also think that without that impl, bang is dramatically less useful.
Yeah, I think, I mean, I feel actually not so bad about the hack in the sense that Taylor's logic, while complex, is a way to, as Ariel said, there's like multiple routes to reasoning through that impl, one through specialization and one through overlapping.
So another reason why I think a hack is a good idea is because it might be useful in other cases. Like if you have a way to reserve implementations, then the libs team could presumably use this for other types of coding.
Can we come up with a more distinctive way of referring to which hack we're talking about? Because there are at least two
Let's
or
call
maybe
it
different
the
crazy
reserve-
hacks that have been proposed in this thread. So
let's call it the reservation hack. Rust C reserve info or something.
okay. So is anybody not on board with that version of it? Like something that or something stronger?
I'm still trying to understand exactly what impl. I mean, I get the impl. Why is it that impl is critically important for us to provide in order for never type to be useful? And I'd like to have a better understanding of what that impl breaks without this hack.
Because the most common thing that you want to do with never type is say that it's something else, right? So a common example is if you have like a result that returns a type that returns a function that returns result where the error type is bang, you want to be able to use question mark on that and have it like the error type just disappear. And that only works if any error type that your function could have is convertible to from bang.
Oh, I see. Where the error type is bang and it can't error.
Correct. So you're calling a function that returns result with an error type of bang because it's a trait impl or something, right? And then you want to be able to use question mark to just throw that bang away, right?
I see.
well, I think that also like we could get pretty like not obviously this impl is the best way to do that, but we could also like have we can implement error for bang, and then like that's sort of the same as any error inside a library, right? Your response, if you want to be able to convert from it, you have to add it for your own impl.
So that's not actually enough, and the reason, and I can go into the specifics of why that doesn't work out, but basically, a lot of the types that you're talking about here, like, wind up in generic contexts where they're working with a type that is like specifically something that can be converted into a std IO error or something like that, or a type that can be converted into some other specific error type.
Right, but I'm saying that the people who write those libraries, who write those types, would be responsible for adding the from impl, and it would just be another thing that they have to do. But that is another possibility.
So
that's what they're doing today with
Yeah.
infallible, right?
I mean, it's what they're
yeah,
doing with
right.
all error type today.
Infallible is the way people do that today.
So with respect to the pretend reservation thing, the main question I have is who is going to implement it and who knows how to implement it. Maybe Ariel could do that. Maybe. Or do you think you could do that?
I think, well, I don't know if I'll let Ariel answer.
Isn't they?
I think I could mentor someone through that too. I don't. It's either really easy or it's hard. I think it's probably really easy.
Those are the two options.
No, there could be medium.
Okay.
Do any of the hacks that are discussed have implications on being able to convert infallible into bang? Or is that going to be fine no matter what we do?
Well, I mean, the thing about this
Someone
hack is
infallible is.
that it's a choice to make it like it's not possible to implement from bang for any type now. If we say that even though the impl does not exist, you cannot rely on knowing that it doesn't exist.
I mean, so actually, Scott, that's a good thing to point out is that technically today, if somebody did have this, if somebody was doing this negative reasoning to see that core convert infallible was, but they can't because core convert infallible is defined inside the standard library. And so they can't have that negative reasoning about it because somebody might add that from impl. Okay, never mind, I take it back.
Wait, Boats, maybe we should clarify because Boats raised a point that did not meet my expectations. What this middle reservation option is. I was assuming people would still be able to write for their own types, but
not if they have to assume that this. Not if they have to be backward forward compatible. Like, 'cause this is more compatible with adding from. If like I wrote from bang for my error, then that's the kind of code that will be broken by adding from bang for t, except modulus visualization, etc.
Well, I was assuming that you would be allowed to write it for your own types, but you're not allowed to rely that other types.
The other types, the
that
generic.
your own types even don't have it, and therefore you sort of can't do this pattern. I guess this pattern you wouldn't be able to do.
So, Scott.
Yep.
I don't know if you saw, but I just wrote some code about the core convert infallible case where like you can do the same thing with core convert infallible today. So if anyone is doing that, and then we made core convert infallible equivalent to bang, we would be breaking that code. I don't know how many people have actually done negative reasoning based on the fact that like you
I
can't
think that this is code that is
core convert infallible, but like
I also think that this is like a really implausible situation.
You're not allowed to write that impl today, are you? I don't think you are, because
why not?
You don't own any of the. You can't do negative reasoning on types you don't own.
Yeah, I think that's.
But you do own the type above. Here, let me comment this out so it's less confusing. You own foo, and foo is the thing you're doing negative reasoning on, and you can reason that foo is not from core convert.
You're right. You're right. You can do that. I didn't understand what you were saying, but was someone proposing that? I don't even know what infallible is. I have to admit, what is infallible?
It's the thing that like all of like the like from stir impls and stuff like that are infallible return now.
It's a library defined bang.
Okay.
Yeah.
Yes.
It's we couldn't stabilize bang, so we made this thing instead. So that.
But I mean, all of this stuff is just like it's this like whole thing is really frustrating just because it's like we're trying to make the most perfect possible, like where everything is written for you using these magic generic impulse thing, and it's not working. And instead of being like, okay, that doesn't work, what is sort of the like thing that does work that like maybe people have to write a from bang impl for their error if they want to convert a bang into their error type. Like instead we're like talking about adding hacks and like delaying everything. Like now it's been years and it just feels like
the alternative is the absolute worst case. I agree with. I hear you, Boats.
I mean, one of the concerns, like as I understand it, there is if people write the from impl themselves, and then we figure out a generic way to say you can always convert bang to anything, do those two things conflict?
Yeah,
if we can find a way to make them not conflict, then we could go ahead and release now while we sort out how to make that generic implementation. But if we're not confident.
The problem is the negative reasoning. We need to prevent the negative reasoning because otherwise people could do things with associated types. For example, if they do this type out and then give it one value there.
Like, this negative reasoning isn't actually hard to arrive at after like writing some code that looks sort of like this. Like if you're writing a generic error type, I can definitely see someone writing something that looked like this.
So if we're only blocking the negative reasoning and you can still implement from bang for your own types, then I think that's fine. I don't think that's like I'm not optimistic about ever having a specialization that allows.
Yeah, I mean, how do you feel about how do you feel about us just like hacking, like forcing that impl to exist?
I also think that's fine. I think that like
I that's my preferred route, just because this seems like something that we've wanted to add for so long. And we have like the justification for how to write it in a library form is so difficult and like
I just would rather like have this be stable with nothing than spend another 6 months arguing about whether or not it's appropriate to add that hack to the language. Like that is like.
So is anybody? I think Central, you mentioned that maybe you didn't like that. Does anybody else? Or Central, do you want to talk a little bit more like about your thoughts around that?
I'm not sure I feel that this hack is justified in terms of.
Okay. Do you want to talk with me offline about that, and we can decide whether that's something that worth pushing on? But I think we're all on board for the like impeding negative reasoning hack.
Right. It seems so.
Okay.
So maybe
we don't have to block on that then.
So I think it's a good idea to investigate the negative reasoning, but I also think it's a good idea to try to bottom out this impl because I also feel like at the end of the day, if we had a special case impel, I could live with it. But
So
bang is a
I
special
mean,
type.
like from and bang are already like magic. Like from is already involved using sugar. Like bang is already
Right, that's what I mean. They already know the language.
Right.
Yeah.
We already have a magic cohort for this, right?
So I'm thinking, Nico, that you're pretty busy. So maybe if Ariel has time, you could do it.
I think I do. So I'll. Yeah. Do you want to try to get up a prototype for the impeding? Yeah.
Yeah, that's fine. I'm happy with that.
Yeah.
But okay. I'm happy with that, but I feel like I would probably be happier with the from bang. So I'm wondering, the last question I'm going to ask is, what would it take to make us feel sufficiently confident that we would have some, like, is a route to getting this central that the only route is that we have a stable path, or we feel like there's something with sufficient probability that we'll have a path to justify it in a non-special.
So the coherence problem makes me like doubt specialization, like that we can do it we know how to do it soundly a lot. So it's hard for me to like trust.
It sounds like we're very far away from a like concrete rationalization of specialization that would allow this, right?
I don't think you're going to be able to specialize on from. That was my understanding of the.
But
the marker trade rule is another route.
Yeah, there's also my like magic, like if all the associated items are functions which are uninhabited or something, like which take uninhabited arguments, like the
marker.
You can get here a million ways. So
yeah, that would be interesting.
Well, I think if the negative reasoning is easy, we can start with that, I guess. I agree with both. Yeah. The delay is the worst part.
Can we include an explicit test that involves an impel of from bang for a specific type or similar, or for that matter for a type a trait, like everything that implements a trait, and just make sure that test passes with whatever hack we have?
Can you write down the thing you want?
Do you mean like in the PR, Josh?
I'm saying, yeah, in the PR, can we add a test case to the compiler for impel from bang for specific type or similar?
Yeah, that sounds good. Can you just write it down so we remember?
Yeah, I'll write it down.
Thank you.
As a passing note, I do want to mention, Boats, though, that the first time we tried to stabilize this, it actually got called off because, and only because it turned out that the libs team was going to recommend against it because of the whole Bach-Stein error conversion failing. So
it's a good point.
Yeah, though I don't mean
like historically it doesn't.
Yeah, we could have just implemented error. I don't know why.
Let's not do.
It actually did. That was but that was a bug that got fixed. It was an issue with it tried to coerce it too early, and so you were passing an unsized value to box new. But
so
let's talk about the other problem. But I do
move on.
Would be nice to add the input. All right, so we have this other problem that we've been putting off for a while, so we wanted to talk about it, about coherence being bypassed. And Ariel, do you want to sort of show the problem to start? Do you want me to do it? Right. I mean, the short version is that we have a rule. We say that din foo implements foo, and we have a rule that sort of prevents you from writing very simple impulse like this. However, that rule is not especially smart, and you can create more complex impulse that will kind of bypass it. For example, this. And in fact, we're kind of relying on this in the compiler, I found out later. Anyway, through some horrible, it's not particularly important, but it's annoying. So this would be like, now the problem is this impel T is din foo, the simple applies. So that's not great because now we have two definitions. We either have the built-in din foo foo, or we have this simple, like two ways to kind of implement the trait. Whoever's typing is very loud.
What code actually gets called with this today if you call a method on the trait object?
I think the trait object, I think what happens is we go through the vtable dispatch, because by the time we monomorphize, we'll... So Ariel weaponized it.
The problem is that you can have an associated type, and then you can have very easy unsoundness with that.
Right.
You can basically encode transmute safely.
Yeah. So I didn't. Yeah. Sorry.
Yes, and there was a.
There's a small. I have a comment that encodes like a smaller version of it if you want to see them.
Yeah, that's good. There was another issue somewhat related to this. Maybe it was even the same issue that we ran into before. I'll go look at it in the screen. I'm not sharing with everybody. It was by who filed it? Anyway, I'm going to look for some background. But I mean, we can't. I remember we encountered a similar issue when we toyed with different rules to rule out overlapping impulse.
So the one idea I had is that we would probably propagate the constraints, but I think found ways to make that not work. But basically, I wanted to blame ISO 2, but you can make
Yes, so I basically found out all the reasons why we do want to have coherence. Why we don't want to give up on coherence, because you could, at least I can't think of at least for every example that every way to break coherence that it looks like it works, I can come up with some way to make it unsound.
There's some more discussion.
Do you want to walk through an example or two of those just to give us a flavor?
I'm not that. I don't remember them exactly. They can get a bit complicated, but.
So this was the other issue that was related. That I think was related.
So presumably someone like checked what happens if we just disallow this and it doesn't, like, a bunch of stuff breaks, right?
You just disallow this kind of impl?
Correct. Disallow. I mean, correctly realize that this is an overlap with the impl for the trait object.
I think what we were. Well,
I don't know. I don't really understand how.
I think what we did, the solution we were pursuing for this other problem, which I think is the same, although I haven't. Yeah, I think it's basically the same. Was to make this trait not object safe. If there exists.
Do we have any like rules at the moment which check impulse to determine whether a trait is object safe or not?
No.
Make a trait object safe if there's an impl that would apply to its dyne.
No, make it not objects.
No.
Correct.
Which so has to exist in the.
Exists, you would make it not object safe.
Yeah, and it would have to, like, that's also fine because it has to exist in the same crate, because it would have to be a blanket impl or an impl for the, like, it would be an orphan in any other crate.
That said, it's interesting. We said we had future compatibility warnings in place around this issue, but maybe we don't. Or maybe they're not sufficient to cover this case.
So the encoding plus mute example there, you don't get any warnings about that.
No, okay.
So in that case, in that specific case, you could get around it with an equality constraint by propagating it on foo, I think. But I found ways around that, and they're a whole lot more complicated.
So
the third option basically make the object candidate impel have a where clause that requires that no other impel applies.
So you kind of you're saying here, Ariel, is basically like abandoning the. Essentially, there's two varieties of. You can write an impel by hand for your DIN type if you like. Otherwise, so that's how I understand that. You could write this impel by hand if you like, or indirectly, and you're allowed to do that. But if you do it, then you don't get the automatic impel, essentially.
Yeah. The automatic impel only applies if no other impel can apply.
That seems pretty okay too.
So
I go ahead.
Think about how to do it though.
So I haven't read Ariel's latest examples on Zulu in detail. They will require digging into that one. But so the one thing I think would be good is that we test out different solutions, since there seem to be different solutions that are workable, and find out how much would break and how much it would affect compile times and stuff. So because otherwise it's sort of hard to decide right now which approach is better without having any data.
Yes, I agree. We should do some testing. But it seems like the last one, at least, seems to have the relatively minimal potential for breakage. But we have to write it out a little more clearly what it means.
And
especially around more complex traits.
I like the last one. I think that the thing that Arthur wrote a couple of years ago about making there's some relevance there.
It's kind of annoyed me that we can't. There have been times I wanted to write the simple in any case. Usually as a way to make the trait object safe. But
so, do you think this interacts with the rebalancing coherence in any way?
I don't think so.
Yeah,
it doesn't change any of the. It doesn't change any of the rules for other traits.
One thing that might apply. I mean, am I correct? I think I'm correct to say that if you had an impel, if you wrote your own impel of foo for din foo for all possible instantiations, or even not for all possible actually, then in a sense that could make the trait object safe even if it wouldn't otherwise be. This might replace the where self-sized hack. The idea would be essentially I write a trait that includes non-object safe things, then I write an impel of that trait in terms of the dynamic version of itself, but I can only use that it would require us to
This one has a PR to implement it. That's nice.
Yeah, it does, but it's only semi-relevant.
The PR won't, I don't think, solve this problem.
Yeah,
but it does do some of the work. It does kind of do some of the work we might want to do if we solve this problem.
Yeah, it's just worth considering in terms of relation.
Just been rebasing that PR today. I think it passes test now.
But I think, I think that what you're describing where you could not have the where self-size thing seems obviously awesome. But doesn't that run into you want to dispatch the object safe methods, or at least probably the unprovided methods at least, to the vtable.
It's kind of getting rid of the idea of the other route has always been that we get rid of the idea of object safety, and we instead sort of say that you can have a trait
How do
object.
you actually get the call the vtable methods if you're providing the impel yourself? That's the thing we would have to decide.
Right, that's the thing you have to add back, or else you can't do it. But you have to have some. It makes the language. It could be done as a future step. I don't know if it's a good idea or not, but I'm not crazy about the where self-size tag. You basically have another kind of call.
Yeah,
it's not right now. We route the vtable methods sort of through a special magic impel. This would be that you want to route them through a special. There's just like they're like an inherent method. The compiler knows how to generate them.
Yeah,
So,
I mean, or even this could be connected to the RCs for having an API for accessing the vtable. That the vtable could like you could have some API for getting the function pointers for these methods out of that vtable type, right? Like,
yeah, I guess that would be like the low-level version. But yes.
Yeah, it would not for most use cases, it would not be pleasant to have to then like write that to call them.
Yeah.
But
The problem with having an impl like that is that you want to have the plus sync, plus send stuff. If you just impl iterator for din iterator, you don't.
That's a good point. Yeah. So yes, very good point.
So one way around that might be to like be able to quantify bounds. You could say dyn iterator plus some bounds you have quantified.
Anyway, this is like we clearly wouldn't want to go this far in one step anyway. Or solve the soundness hole, but it is interesting.
Yeah,
like,
it's not. Just being able to get rid of object safety would be very nice. So,
well, what I like about this, if we did go this way, is that the main downside of getting rid of object safety when we first considered it was that you had to write these impls.
Right. If it was instead just
now it's like you don't have to, but you have the choice.
Object safe means that we can write the impl for you, but you can
instead. Exactly.
That sounds nice.
Because before that was a real drag.
Object safety is also a concept that many people find difficult to understand. Like,
but yeah, that's why it'd be nice to get rid of it.
Yes. Yeah. It hasn't aged well, I think.
Count me up.
Well, it's hard to check for and a bunch of things.
It's very leaky. It's just like here's a bunch of random rules that are
exactly. That's exactly how it feels like.
And people do it by accident a lot.
The problem is those rules don't go away. Under any of these versions, like even in this version, the rules just sort of move around. Then they're like, what can you do? But I still think this might be an improvement, nonetheless.
Taylor, it looked like you were trying to say something and you were maybe on mute. And we're still not hearing you. Or I'm not.
I don't hear anything.
Okay.
I guess question, Ariel.
Can you hear me now?
Yeah,
I can hear you.
All right. It seems like sometimes Zoom just decides that I don't get to be heard. I was just gonna say I kind of want to push back against the idea that we want to make fewer things object safe, or that we would get rid of object safety somehow and make it always manual. I feel like there's already enough sort of punishing that we do of Rust users trying to use dynamic dispatch. And I feel like adding more things to that list would be bad.
Yeah, no, that's definitely not what I mean. I mean, like, it would be ideal if, we could just, if all the traces in standard library were somehow object safe, would be, it is, if, but, yeah, as Nico pointed out, this just moves around the problem, because you still have to implement it.
Yeah, I mean, you were there at the all hands when I tried to scheme out and was pushing for trying to make, generic methods object safe, and it all kind of fell apart.
It would be ideal if that would be what would be awesome is if there was object safety, because everything would just object safe.
How is that going to work without parametricity?
It didn't work.
It doesn't work.
And yes, parametricity is definitely a huge part of the problem.
If I might ask a weird general question here, is there a clearly documented version of this test case that includes a careful walkthrough for people who don't trivially translate type system rules in their head?
So there are, I think the simplest version is probably the one I wrote, and there are a bunch of different versions. I can try to leave some comment.
Sorry.
Sorry?
The simplest version is what one that you wrote? Sorry.
In the paper document it builds up a method called transmute, which is safe. But also I had to stare at it for
I'm reading that example and finding myself wishing that it had about twice as many comments as lines of code.
Yeah.
I'm baffled here.
So I can try to add some.
I'm not asking for an explanation in this call. I'm just making the observation. In case it felt like everybody was completely following along here, am I the only person who's just baffled by this example?
I think some of us have spent a bit more time thinking about it, so that's probably it.
I spent like at least 3 or 4 minutes before I started speaking, staring at the example, trying to understand how it worked. So
yeah.
You're not alone,
Josh. I will try to add some comments after the meeting.
Right. It does feel like we've had a couple of things in a row that involve type system issues around Dyn, and I'm wondering to what extent we might need to step back and look at what is the coherent type system around Dyn, because it does feel like we're patching it incrementally.
I mean, which are the other issues you're thinking of? There's one here listed here, but I'd like to have a full list.
There's the one listed here, and it may be the same one, but I seem to recall seeing another case that was like, here, we can implement transmute.
It would be good to get a list. I think they all hinge. Well, I want to go review this other issue. I guess we could do it now, but they tend to hinge around exactly this sort of interaction of us trying to make an automatic impl. So it might be that indeed we can sort of solve them in a fell swoop. But
so regarding trying out some different options and seeing what falls out in terms of testing, we sort of need a plan for doing this. Someone who is familiar with the parts of the compiler that does this and who could try some things out. I suppose that's like Nico, ScaleMax.
Yeah, ScaleXM might be into this, or Ariel, depending on how much time Ariel has. We could certainly ping and discuss that.
Sure.
I think ScaleXM might be a good thought, especially I would want to prototype some of this in Chalk too.
Yeah. I think it would be a good idea to have someone prototype this, try to figure out how this fits with Chalk. So at least, even if I implement it, I'd like to talk with ScaleXM about it.
Yeah, my main concern with the last one is going to be something around, you're sort of having to evaluate whether another impl applies.
Yeah.
Without the assuming that the din foo rule isn't there. Like it's like a changing set of impulse that we're growing, right? Which is okay. We can do that. That actually seems fine, but it's just want to make sure we don't get them using hot water.
Would it be any use to talk to Richard Eisenberg and Stephanie Wire from Haskell?
Maybe. I mean, there's a lot of context to supply. I don't think we're there yet, but it makes sense. You should probably investigate first, but we should at least do some of the groundwork.
Yeah.
Let's ping ScaleXM tomorrow or later today and see what they think. I think what needs to be done right now is to write up in more detail what's been said here.
Right. I think so. Josh, it took some time for me to understand the example as well, but I think I'm at the point where I'm not having difficulty understanding the things.
Yeah, that sounds like a conversation we should have out of band. I'd just like to get a better idea of where is the actual problem here. I see the result. I'd like to see where along the way something went horribly wrong.
Right. So, writing up some stuff would be good. Who can lead this from Nico, maybe?
Yeah, I think I could try to do that later today. After my next meeting.
Cool.
Yeah, I can't do write-ups in a reasonable amount of time, so you'd rather not have me do it.
All right.
I can do a write-up for the basic example. At least.
Yeah, I was more planning to write up the alternatives and try to sketch them out in a little bit.
Right. I will try to write up an example, some comments on.
All right, good. So central to write an elaborated example. And why is your name in Java Weaver not central? How come you have a name? It's so confusing to me. And
yeah,
I'll try to write up the potential solutions. Okay.
I should get it legally changed.
I agree. I wouldn't object at least.
So, does anybody think that in the remaining 8 minutes we might be able to reasonably at least make a little forward progress on the unwinding through FFI question?
I would at least appreciate a summary if anyone has one of what is the.
So I'd be happy to try to give as neutral a summary as I can, with the disclaimer that I'm also one of the involved parties, but I will try to summarize as neutrally as I can. There is an issue where certain C libraries have error handlers that are effectively, we call abort if you return from this error handler. And the expectation was always, print some messages. You can either print some messages and then abort, or you can long jump up past the library code back into your own code, and that's how you get to keep going if this fails. One of the examples of this is libjpeg, for example, where if you have an error parsing a JPEG, then you get to long jump up out of libjpeg in order to not crash your whole, say, browser window because you failed to parse an image. Mm-hmm. This is a lovely historical artifact of C error handling that we sadly have to cope with. And in Rust, people handled this by using panic as effectively long jump. They would do a panic inside their error handler, allow that to unwind the C code in libjpeg, and then catch that panic in the Rust code that called libjpeg. And they didn't make any assumptions that libjpeg was still usable in that context, or that it didn't have a bunch of screwage inside its internal state, but that they could unwind it. That does require you to carefully build libjpeg with unwind hooks and similar with the right compiler options, but it can be made to work. The problem with this is that LLVM has a flag, no unwind, which is, I promise not to unwind past this function. And we currently declare all extern C functions with that flag, which means they can be misoptimized as assuming that they will never have a panic propagate past them. At one point, we actually tried to fix this by making it so that if you unwind past an extern C function, we would abort rather than unwinding. And this ran headlong into this broke people, like the lib users of libjpeg. Everybody involved understands that there was undefined behavior here and that there is a problem. And the last time people tried to push this, it got reverted, but there was a feeling like nobody made any forward progress on it. So this time around, we effectively said, let's revert it again, but let's put a 12-week deadline on making some kind of forward progress to actually solving the problem. And if we don't make any forward progress, then we'll just declare it as we're not reverting it again and deal with it, fix it, if nobody stepped forward to fix the problem. So that had the intended effect. People stepped forward to try to fix the problem and to write a real RFC that is, here's how to make a function not get marked as no unwind, here's how to deal with panics. That has currently got caught up in a fair bit of detail about, well, what does it mean to unwind? What about different panic runtimes? What about exceptions? How does this interact with C++ exceptions and running destructors on the way out? Effectively making the gold armor-plated solution that solves every use case. And it has gotten somewhat distracted from the problem of we need to not put no unwind on these functions or we have undefined behavior. So we're trying to get that back on track. There's a lot of discussion of what is the minimum needed to solve the problem and fix the undefined behavior. But in the meantime, the deadline came up, and there's some desire to just say, well, the deadline passed, so let's reapply the change, or rather, the change was only ever done and reverted in beta. And so if we do nothing, then we go back to aborting if you try to unwind through FFI and existing code breaks. And if we merge this 62505 in beta, then we defer it another 6-week release and allow time for the RFC to wind its way through the process and figure out what it's doing. I personally would recommend that we merge this because forward progress is being made. It would actually be my preference to merge it into trunk on the assumption of let's reapply the other change when the RFC is sorted out. But I'm assuming that there is not unanimity on that.
Well, so first on merging the PR. From my perspective, as long as we haven't resolved this, we should either merge it on, merge the PR on beta, or we should merge it on master. Well, you have to do both.
Okay, that's good to hear at least.
In other words, you would prefer that all 3 channels behave the same. Is that correct, Central?
Well,
Is that what I understood?
So the idea was that we would have some pressure to get to a solution by not adding it on master, but I don't think that is helping. So we can just merge it on master. I mean, I don't have a strong opinion. But as long as
make a quick comment that I think the pressure had the intended effect of we need to actually make forward progress, and I think now that there is a live RFC that is being actively worked on, that until that gets dropped, unless that gets dropped on the floor, I think we have forward progress going on, and the pressure is now more generating stress in trying to actually work on the RFC.
So maybe that, stress is probably not helpful. So, my larger point was just that, until we have consensus in the team, we shouldn't make, we have to find consensus in the team if we are going to make it abort, basically.
I tend to agree with that. I definitely think we should merge this PR. I think that's kind of a no-brainer. I also would be happy to revert beta, to merge it to master, but I do very much want this RFC to make progress.
Right. And the one comment I would make on that is there's been some discussion on 58794, which is kind of the issue that the RFC is trying to address. And I think there is some thought of, could we just add the simplest possible attribute that turns off LLVM's no unwind on a function, and then solve the whole how does panic interact with other things later, and for now leave it with, if you're doing this, you'd better know what you're doing with respect to building your C code with the ability to be unwound. That would be undefined behavior, but I'm wondering if that might make people a little bit less stressed about the fact that we are kicking this down the road another 6 weeks.
I kind of assumed that's what we were going to add.
I kind of hoped that was what we're going to add, and then I go look at the RFC, and it's like, why is this longer than a page?
Well,
this is
describe the behavior of the attributes. But so what's the idea around forward compatibility with other code backends and
I actually have to leave.
not tying ourselves too much to LVM? Right, we're at time.
Yeah, we're at time.
So we are
There's general consensus we should merge the PR.
I think we can merge it into trunk to master too.
Right.
I
would
comment.
So
I think that there's going to be a solution, and we should do everything we're not breaking. We've decided not to break people, and we should just do that. Even though they're relying on defined behavior, they're working on a proper solution, and everything will go well, and whatever. Instead of this.
And I will make sure to talk with the RFC folks and say, it feels like this has grown a little bit. Could we try to do the simplest thing that addresses the undefined behavior and then address the larger solution? I'll try to get that back on track a little.
I'll need to read the RFC again, but I would like to involve Alex and these discussions. From my perspective, I think the wrapping with C solution, like wrapping on both ends, is like a workable solution in the interim. So personally, I would like to change the behavior to evolve. But
all right, I really do have to get off. I have another call. I'm just going to end it though. You all should discuss on the thing or discuss in Discord. Ciao. Thanks everybody.